Okay, welcome back. We are looking at chapter 2.6. This video will cover chapter 2.6 and 2.7 from the thermodynamic textbook. Yeah. So 2.6 is on the first law of thermodynamics. So what is first law of thermodynamics? It speaks about the conservation of energy principle. Yeah, which means energy cannot be created or destroyed. Yeah, neither created nor destroyed during the process. It can only change one form to the other form. Yeah. So the first law states that for all adiabatic processes between two specified states of a closed system, the net work done is the same regardless of the nature of the closed system. Okay. And the details of the process. So we have, you look here, example, just an example. The stone is falling up from a cliff. Potential energy is 10 units and kinetic is 0 because it's not moving. So when it's moving down, if you see the total energy even in the midway will be 7 plus 3, 10. Of course, when it's landed down there, potential will go to 0 and kinetic will be at the maximum. Okay, so if 5 comes in, kilojoule comes in, 5 will be written inside here, or probably if it goes out, the total will always be 5. Yeah, conservation of energy. Any cases that you take. Okay, example 15 is going out, 12 is retained and 3 goes out. So 12 plus 3 is 15. Yeah, so 8 goes in, 8 retains inside. This is an adiabatic process, so there's no heat transfer or work transfer. Yeah, Q is 0. Yeah, okay, then we have work in 5. So the energy change inside here will be 5 because this is also adiabatic. Yeah. For this case, it's not adiabatic. That's the reason why they have Q out, but still Q out and the Q that's written inside, you total up, it will become 15. Yeah. So this is the first law. It is important. Yeah. Next, we're going to look at energy balance. Energy that enters, okay, minus with energy the leaving will be the energy that's written in the system. Okay, let's look at this case here. If 10 goes in, 10 inside, so it's okay, fine. Yeah. But not all the case will be 10 in and 10 retained inside. Yeah. Take example this one. Yeah. 6 work shaft going in. Yeah. And then we have 15 going in. So what do you have here? And then we have 3 that's going out. So how much will be inside? So let's put Q's together first. Yeah. Q15. Okay. What is retained? Q15 minus 3 outside. So we have 15 minus 3 that's going out. This is Q, yeah? Yeah, this is 12 plus 6 that's going in, plus 6 that's going in. So it will become 18. So 18 will be retained inside. Okay, so this is energy balance, yeah? So energy change of a system, we are going to look at the whole system in a bigger picture. Always remember delta E equals to delta U plus delta KE, delta PE. Of course, this formula can be expanded with different forms of energy. Remember that, yeah? Okay. What is delta U? Delta U is more of internal energy. Where to get the value of U? You will see this in chapter 3, where to find the value of U. It's from the back of the textbook. It's known as internal energy. Every molecules, every particles have got internal energy. Kinetic energy is due to movement. So this is velocity, and potential energy is due to height. So these two forms are mechanical forms of energy. Okay. So if it's stationary, automatically KE and PE will become 0. So the energy will be only looking at internal energy. Yeah. Next, we'll be looking at mechanism of energy transfer, E in and E out. So there are 3 forms. One is the heat transfer, work transfer, and mass flow. Yeah. Heat transfer, work transfer, and mass flow. 3 forms of mechanism of energy transfer. Okay, so that's why it's incorporated. Can you see Q in out, W in out, and mass in out? So giving you this big huge formula here. Okay, of course the formula can be simplified based on your case or your situation. Yeah, like you have to analyze the question. It's not same at all time. You have to analyze the question. If they mention that it's adiabatic, so automatically this component becomes 0. Yeah, it depends. And if there's no work done, then of course this component becomes 0. So you have to read. This is the main formula, but then it's very subjective to the question itself. Yeah. So now all this list down here is to show that it is in a specific form. Whereas for a case of cycle, what is a cycle? What is a cycle? Cycle means You start from Sunway, you go to your house and come back to Sunway. Or you start from your home, you go to Sunway and then you come back to Sunway. It's a cycle. You complete the work. Okay, you complete from state 1, you go to state 2, from state 2 you come back to state 1. This is a cycle where work net out is actually equivalent to Q net in. Yeah, that's for a cycle. Okay, now let's move on to example 2.10 and 2.15 as what I have actually told that I'll be covering 2.10 and 2.15. Yeah, let's solve the question. Okay, 2.10 is talking about a cooling of hot fluid in a tank. So this is a very theoretical question, yeah, just for your understanding, and we'll be also going into some calculation shortly. Okay, just read the question. Rigid tank. What does it mean by rigid tank? This is very important. Volume is constant. Rigid tank, you must memorize that rigid tanks mean volume is constant. There's no change in volume. Contains a hot fluid that is cooled while being stirred by a paddle wheel. Initially, the internal energy of the fluid is 800. During the cooling process, the fluid loses 500 kilojoule of heat and paddle wheel does 100 kilojoule of work on the fluid. Okay, so can you read the story? Can you understand the story? So determine the final energy of the fluid, neglect the energy stored in the paddle fluid. So a fluid in a rigid tank loses heat while being stirred. The final internal energy of the fluid is to be determined. Yeah. So assumptions: the tank is stationary, thus kinetic and potential energy is 0. They didn't even mention in the question, right? So we have to assume that there's no kinetic energy, there's no potential energy. Okay. Therefore, delta E equals to delta U, internal energy only. Okay. So energy stored in the paddle wheel is negligible. This is given in the question. Yeah, so you have to solve. So coming to the formula of E in minus E out equals to delta system. So what do you have in delta system? You don't have delta PE, delta KE. Delta PE is 0. Yeah, delta KE is also 0. So when you cancel off each other, you're only left with delta E, which is delta U. Okay, so rewriting the formula again. So we have work shaft in. What is your work shaft in this question? Okay. Stirred by a paddle wheel. The initial energy of the fluid is 800. Initial energy. Okay. During the cooling process, fluid loses. Loses how much? This is Q out. Loses means Q out. Q out. Okay. Paddle wheel does work. This is work in. Can you categorize or not? Yeah, work in. And remember our positive and negative sign. Work in is positive. Q out is negative. So, positive, negative. Okay, equals to delta U. Initial energy is 800. So, final energy is how much? It's 400. So, you just have to plug in the values and solve the question. Now, we're going to move on to chapter 2.7, which is energy conversion efficiency. So what is an efficiency? It's the most frequently used term in thermodynamics, and it indicates that how well an energy conversion and transfer has been accomplished. So it's mostly depending on the desired output over input. It's always output over input. Yeah. So efficiency of a water heater, the ratio of energy delivered to the house by the hot water heater to the energy supplied to the water heater. So yeah, example, yeah, gas conventional only 55%. Electric is very high efficiency, which is 94%. So this subtopic, yeah, will be actually discussing on efficiency. So the efficiency of combustion is actually the heat released during the combustion divided by the heating value or the fuel burned. So what is the heating value of fuel? The amount of heat released when a unit amount of fuel at the room temperature is completely burned or combusted, yeah, and the combustion products are cooled to the room temperature. We have LHV and HHV. LHV is when the water leaves as a vapor, and HHV is when the water is in combustion gases, is completely condensed, and thus heat of vaporization is also recovered. These are few terms that you need to know. Okay, and then we have the annual fuel utilization efficiency. This is just a general knowledge for you. Yeah, okay. So we have few equipments, which is generator, a device that converts mechanical energy to electrical energy. You probably have seen this in Pasar Malam. Yeah, and then we have generator efficiency, which is the ratio of electrical power output divided by the mechanical power input. Okay, now we have thermal efficiency of a power plant, where the electricity output divided by the energy fuel input. So it's always output over input. So this is some tables for you to just go through difference in lighting systems. What is the efficacy of lumens? Yeah. Okay, and then what we have here, let's move on. Still on the topic of efficiency. So using energy efficient appliances, we can conserve the energy. Yeah, and also it can help the environment. Yeah, because combustion produces carbon dioxide, nitrogen dioxide, hydrocarbon, sulfur, carbon monoxide, sulfur, and all. Yeah, so that's the reason why energy is actually very important. We try to conserve as much as possible. We try not to waste energy. Yeah, and try the best to actually maximize and do the utilization of energy. So these are some formulas of efficiencies of devices. Mechanical devices, you can take output over input. Okay, pump example, the fluid divided by the shaft, which is actually the pump's mechanical fluid divided by the efficiency of the pump. Okay, and then we have the turbine also output over input. Yeah, and then many more devices like motor, generator, pump, motor, turbine, generator. Yeah, you can just go through. These are all efficiencies formula. Okay, so now we are going to discuss question, the power generation of a hydroelectric plant. I'll bring to this 2-page later. Yeah, electric power is to be generated by installing a hydraulic turbine generator at the site of 70 meters below the free surface of a large reservoir that can supply water at the rate of 1,500 kilogram per second. Okay, and then we have 7 meters height, right? Okay, possible the things that you need to write down. Yeah, if the mechanical power mechanical power output, yeah, power out is equivalent to 800 kilowatt. Okay, and the electrical power generation is generated is 750 kilowatt. Determine the turbine efficiency and combine the thermal generation of this plant. So how do you solve this question? So if you take the free surface of water, this is to find your MGH, your potential energy. Yeah, okay, what we have, the height is 70 meters below, so MGH. So in this case they are actually calculating in specific. That's the reason why I didn't put an M in front. So it's G multiplied with H, and this is the unit conversion, so you get the potential energy as this much. Okay, then the rate at which mechanical energy of water is supplied to the turbine. So in this case, how much is it? 1,500 kilogram per second. Yeah, multiply with the mechanical energy that we calculated just now. So what do we have? 1031 kilowatt. This working is actually just to cancel the mess. You see, this is actually in the specific value, right? So this working is actually to cancel the mess. Okay, now let's go on. The combined turbine generator and the turbine efficiency are determined from the definition. So we have the turbine generator, which is 750 divided by 1031, efficiency of 72.7, and then we have the electric output, which is also given in the question, which is 800 divided by 1031, so you have 77.6. Therefore, reservoir that supplies 1031 kilowatt of mechanical energy to the turbine, which converts 800 kilowatt to its shaft work that drive the generator, which generates 750 kilowatt of electrical power. So this problem can be solved by taking 1.1 to be at the turbine inlet and using the energy flow instead of potential energy. It would give the same result since the energy flow of the turbine is equivalent to the potential energy of the free surface reservoir. Yeah, so you can understand, right, the step by step. Yeah, if you don't understand, you just meet me during the consultation hours and I can just clarify to you. Yeah, so with this we have actually ended chapter 2.6 and 2.7. I will see you in the next video. Thank you.